Good morning. I welcome you all for the seminar presentation competition of National Seminar on Contemporary Challenges in Processing Quality and Safety of Food. Today we have three experts as judges of this event. They are Dr. Lilia Baby, Assistant Professor KVK Tavanur, Dr. Binucha Thomas, Principal Scientist, Kerala State Council of Science, Technology and Environment, Dr. Lakshmi E. Jayachandran, Assistant Professor, Kerala University of Fisheries and Ocean Studies, Kochi. Attention. The guidelines for all presentation are a soft copy of your PowerPoint slides has to be submitted at least 1 hour before the presentation. Strict adherence to the time limits 10 minutes for the presentation and 5 minutes for discussion. A warning bell will be there at 8 minutes and final bell at 10th minute. Your presentation will be evaluated based on the following: novelty of your research, presentation and communication skill, time management, quality of your slides, their content and logical sequence, your ability to respond to the questions and comments on the audience. The decision of judges will be final. They can use pointer. Here we call upon our first participant, chess number SC001.
Good morning, all. I am Devi Krishna. I have completed my MTech in Dairy Engineering from National Dairy Research Institute, and currently I am working as a teaching assistant in University Dairy Plant, Kerala Veterinary and Animal Science University, Manuti. So today I am going to present a presentation on the title Optimization of Electrohydrodynamic Process for Encapsulation of Lactic acid Bacillus rhamnosus in nanofibers. Actually, electrohydrodynamic process is a nanofiber fabrication or nanocapsule fabrication method. It could be either electrospinning or electrospraying. In my study, I used electrospinning for encapsulating Lactobacillus rhamnosus, that is a probiotic in food grade polymers. The polymer I have used is Pullulan for encapsulating this probiotic. So this is the outline of my research. I encapsulated probiotics using electrospinning, and encapsulated probiotic is added to milk for preparing curd to check its viability, whether it is viable after encapsulation. So this is the standardized procedure of my work. I dissolved Pullulan in water and heated up to 90 degrees Celsius for making a sterile environment. Then Lactobacillus rhamnosus was added to the Pullulan. And this solution, the Pullulan probiotic solution, is electrospun, and dried probiotics is stored at 4 degrees Celsius. So this is the electrospinning unit which I was used for my study. This unit consists of major three basic components: a high voltage supply of 1 to 30 kilovolt, then a capillary tube with spinneret, and a metal collector which is used to collect these dried probiotics. So the process was optimized using Taguchi orthogonal array design, and the parameters selected was applied voltage, concentration of Pullulan, and type of protected at three levels: applied voltage 80, 20, and 24 kilovolt, concentration of Pullulan 12, 14, and 16 percentage, and protectant to protect this probiotic from adverse environment. Maltodextrin, sucrose, and lactose were used, and the response factors analyzed were viability of the microorganism and its survival rate. So the number of trials I have taken, 9 trials and 3 replications, and S by N ratio, which is signal to noise ratio, which should be larger is better for both response factors, that is viability and survival rate. So this is the plot for S by N ratio, which is clear that at high S by N ratio, that is 18 kilovolt, 12% concentration of pullulan and sucrose as a type of protected, S by N ratio is high. So these are the optimized conditions, that is 18 kilovolt of applied voltage, 12% of pullulan concentration and type of protectant. So this is the contour plot of survival rate, which is shown that at 18 kilovolt of applied voltage and 12% of concentration, at 12% of concentration, survival rate was greater than 85% at optimized conditions. So I have also done SEM analysis, which is shown. This is a pullulan solution without probiotics, and this is the SEM image of encapsulated probiotics using electrospinning. And I also analyzed the fermentation kinetics of dahi prepared using electrospun probiotics, and from the results it's clear that pH and acidity are almost similar as that of control, while viscosity is slightly higher compared to control because we are adding polymers, so it increases the viscosity of curd, and probiotic count is slightly less as compared to control. So this is the dahi made with electrospin, Lactobacillus rhamnosus, and the work was successful as it could be an alternative method for encapsulating microorganisms, and also it could be an alternative method for drying microorganisms. Thank you.
The seminar is open for discussion.
So Divya, it was a nice presentation. So what is the advantage of electrospun dahi over normal fermented dahi?
I have not analyzed its characteristics because it's completely how probiotic will respond to this electrospinning process. That is the major objective of this study, because actually I'm an engineer, so texture characteristics and all these things I have not taken into consideration.
Okay, what is the major recommendation of this particular project? What is the outcome?
Commonly, freeze drying is used for drying microorganisms, either freeze drying or spray drying. These two methods have its own demerits because freeze drying is a very lengthy process and it's very freeze dried cultures are very expensive also. Spray drying is we are using at high temperature, so it will damage its survivability. In this process, actually this is a electrospinning method is currently used in textile industry on large scale. They are using needleless electrospinning method, and also this process we are doing at room temperature. It will not muchly affect its viability of microorganisms.
So you have mentioned different applications of electrospinning. So do you feel that electrospun product, dahi, like whether it is good for health or any quality standards or analysis is being carried out? Any reference available with you?
No, actually, this is the first. I have referred so many articles, but in Delhi, nobody has done any research in this thing. So now, currently, research are going on in our institute.
Okay, what is the shelf life?
Shelf life we got as like as a normal Delhi.
How many days?
Shelf life study also I have not.
What is the shelf life of normal dahi?
Normal Delhi is around 7 days.
7 days?
At refrigerated temperatures.
Yeah, again, storage conditions you have to mention. Yeah. So the other one, 7 days, normally it won't go for beyond 1 day. Okay. Okay.
Okay, it was a good presentation.
Thank you, ma'am.
So what ma'am told, I also have the same opinion that you should study that shelf life period, and also the effect, nutritional quality, effect of this electrospinning on nutritional qualities of the heat. Okay, you can further for PhD or something like that.
Okay,
You have
okay,
to
ma'am.
do.
Thank you.
Okay, thank you.
Hi, I just have one doubt in your slide number 10. If you can just show. It is written fermentation kinetics.
Ah.
So what kinetic parameter have you shown here?
No, actually, I have drawn, means I have analyzed at regular intervals fermentation kinetics like acidity, pH, viscosity, and its count.
Yeah, that's fine, but I don't see any kinetic parameter which will describe the kinetics as your title says. So do you have any idea about, or can you explain what do you mean by kinetics?
No, actually, in my understanding, regular intervals will analyze all these parameters. That is,
Okay, according to my understanding, there are some parameters which can show the rate at which the reaction is proceeding.
reaction rate and all I have not calculated.
So, but maybe then the title should be changed. It doesn't show any kinetic parameter.
Okay, ma'am.
Otherwise, the presentation is good.
Okay, thank you.
Thank you.
Judges, please note that was test number SC001. Now I call upon the next participant, test number SC002.
Good morning to all. I'm Nurbina Razak. I'm currently doing my MTech in Processing and Food Engineering in KCAT. So I'm here to present a research on the topic, the evaluation of microfiltration of tender coconut water. So these are the contents to be discussed. So moving to the introduction, the tender coconut water, we know it is rich in the nutritional and therapeutic properties. So it is consumed as normally as a refreshing drink or as a oral rehydration medium, or else it can be consumed as a sports drink also because of the presence of these electrolytes like sodium, potassium present in it. Then it is rich in the amino acids, enzymes and all, which will prevent the heart disease and can be used as a diuretic. So why we need to process this means a normal condition in natural, it will be inside this thermal cavity. So it can be stored up to 30 days. But when we open this, it having a shelf life up to 1 day or 2. So it is get easily spoiled by this higher enzymatic activity and this activity of microorganisms. So we need to process this. But normally this thermal processing mechanisms, they will increase the shelf life, but it will loses its nutrients and the flavor of this tender coconut water. So technology, which is this microfiltration, which is a low pressure non-thermal technique in which we are passing this water through a very small porous membrane in which it will remove this bacteria so that its shelf life can be increased. So why we need to do this microfiltration is that it will not lead to any vitamin or mineral losses since it is not treated like any other thermal processing, and also a low operating pressure is required and a low energy consumption is required for this process. So the objective of this study is to optimize the process parameters for the microfiltration for the process of the tender coconut water and to evaluate the shelf life of the membrane separated tender coconut water. So the materials and methods, we have this microfiltration setup in which we will be passing this. This is a booster pump through which we are passing this tender coconut water through this. The part which is marked as F is the microfilter. So when it is passed through this, there is a needle valve. We can control this. There are two pressure gauges at on the both side of this microfilter. Through this, we can maintain the pressure level we want. And there is a rotameter, which is the part K, through which we can control the flow rate. So the independent and dependent parameters, the independent variable is the transmembrane pressure, and the dependent variables are the permeate flux, ascorbic acid, titratable acidity, the total soluble solids, color, pH, mineral composition, and the microbial count. So the procedure is that before doing this microfiltration, we are washing this setup with a distilled water for about 30 minutes, and we are taking this sample in a beaker and is pumped into that fiber module. Then we are maintaining a required pressure level. Then the quality evaluation is that it is done by determining the pH by using a pH meter, then the TSS by using a refractometer, then the color using a colorimeter, then the titratable acidity is done by using this AOAC method, and this ascorbic acid is discovered by the Sadashivam and Manikan method. Then the shelf life analysis, the microbial study, and the sensory analysis has been conducted. So this is the samples that is then the first one is the fresh sample, and the other three are the treated samples. So the resultant discussion in this variation of the permeate flux during the membrane filtration. So with the increasing in this transmembrane pressure, we can see there is an increase in the permeate flux. But when it comes to the total soluble solids, it is decreased in that treated sample when compared to the control sample. So it may be due to some large solid particles, like the cloud forming particles may be retained on that filter due to its large size. And the pH, it is found that the pH is decreasing from day to day when it is stored. It is because of the fermentation of the polysaccharides on the formation of the free acids due to this some acids present in this. And the titratable acidity, it will increase when this pH is decreasing. Then ascorbic acid is also found to be decreasing, that is due to some anaerobic decomposition method. Then the mineral composition for treated, this T1 is the control sample and other samples are the treated. So there is a less a significant change only is there. So most of the minerals are retained during this microfiltration. So the microbial analysis for the samples which is treated with 5 psi, we can see it is microbially stable up to 14 days, and all other samples, the count was too numerable to count. And for fungal, for treated sample, there was no fungal growth, but for the control sample, when it comes to the date 21, there is a growth. And sensory evaluation, the highest overall acceptability for the control sample, which is a fresh sample, and the sample which is treated with this 5 psa, it having a comparable acceptability with that fresh sample. So as a conclusion, so this tender coconut water is consumed as a refreshing drink, but it is very sensitive to deterioration. So we have to improve its shelf life. So we are using this microfiltration as a method. So during this microfiltration, it will become more clearer. The treated sample will become more clearer, and also found that the 5 psa transmembrane pressure, it have a better storage life up to 14 days. In the future works, there is a scope to standardize these emerging technologies like high pressure processing and perf treatment to retain this quality and shelf life. And also the storage studies could be conducted on the microfiltered tender coconut water by evaluating the total sugar content also during the storage period. So that's all. Thank you.
The seminar is open for discussion.
Okay, that was a good presentation. So, tender coconut water, that is already available in market.
Yes, sir.
In packed forms.
Yes.
So, why did you arrive on such a processing technique?
So
My question is like, what are the disadvantages of the product? What is readily available in market?
because the taste of the natural taste is entirely different, because when we are treating with this thermal processing, it will entirely decompose that it will what the nutrient content will be lost, and also this taste will be entirely different from that of the original. So microfiltered, it will be somewhat similar.
Okay. Now you have tried with the 10 psi and 5,
Five,
5 then 10 and
15 psi.
15. So what could be the reason for that variation with regard to 10 psi and 15 psi? What would be the actual change? Why that change is happening?
Because when we are in microfiltration, maybe due to that pressure, it will, when we are passing, when we are giving a higher pressure, it will move, we will get a more permeate. So during that pressure variation, maybe when we are increasing the pressure, maybe some more particles will be passing through it.
So that kind
maybe
of analysis, could you make it during that your trials? Which all components are being filtered out, or specifically microbes only are being removed, like that?
no, not like that, but
Okay. Okay. So another thing is, how did you collect the samples?
from the instruction farm.
Farm only, and how much quantity is required for particular one analysis? One
Almost
micro
500 ml sample was taken at a time.
500 ml sample is required, and time required for the entire process.
Time required, I'm not correctly. Yeah.
No,
Because
one
I am
batch,
not the person.
one batch. How much time is required for filtration?
I correctly don't know.
You didn't know, notice it all.
I didn't because I am not done the process. Juniors.
Okay, tell me how much time is required for one batch processing, one go.
I'm not sure. Maybe.
Say half an hour required for 500 ml.
Maybe.
10 minutes.
I'm not sure about that.
Okay, you can change the speed, I think, right? Accordingly, that filtration process, various effects will be varied and all. Okay. So now, have you done that other analysis of the final product?
That
Apart
mineral
from sensory evaluation,
mineral
quality analysis and all?
yeah, microbial analysis, then mineral,
Okay.
ascorbic acid, titratable acidity, like that.
Yeah, that all done in your lab itself.
Yeah. Mineral composition is done in that university. It is given to university.
Okay.
My question is, after this microfiltration, how much quantity coconut water you are getting? You told that 500 ml you are using for doing microfiltration work. Then after the end product, how much quantity you will get? Same.
Not same, somewhat reduced, because we are repeating the process up to we are getting that maximum permeate. So maybe some particles will be lost. That actual the tender coconut water will be very in a cloud form, not clear. It will be after microfiltration, it will be clear. So about 100 to 150 ml, maybe it would be lost.
Maybe reduced. Okay. Then how at normal temperature or room temperature can we store it?
No, 4 degrees Celsius.
4 degrees Celsius shelf life,
Shelf life.
after your study means it is stable up to 14 days.
Yeah.
Okay.
My question is, you have done ascorbic acid estimation, right? What is the unit of ascorbic acid? I didn't see it, that's why I asked. Maybe you missed it out. Okay. Shelf life you estimated based on microbial load.
I am a microbial load, and for the TSS, ascorbic acid, all are done.
But in your first slide, you had mentioned that for any food product, particularly fruit product, enzymes and microbial activity is of importance. I didn't see any mention about enzymes, not even in the future scope of work you mentioned. So are you planning to consider it, because enzyme activity does affect the taste and color of coconut water? And you have to find out whether there is any impact of microfiltration on enzymes. I didn't see any mention of that. So maybe this is a suggestion. And ascorbic acid, do you know the unit?
No.
And then how did you do this experiment on your own?
No.
Okay. Thank you.
Thank you. That was test number SC002. Now I call upon the next participant, test number SC003.
Good morning to all. I am V. Harita, MTech student of KCAT Tavanu. I am here to present the seminar on modification and evaluation of jackfruit seed peeler. Project team members. These are all the contents to be discussed: introduction, objective, materials and methods, result and discussion, conclusion, and scope for development. Coming to introduction, Artocarpus heterophyllus, it is commonly known as jackfruit. It is belong to Moraceae family. Jackfruit is rich in nutrients which include vitamins, carbohydrates, and phytochemicals. It is originated in the forest of Western Ghats in India. In India, the major jackfruit growing states are Kerala, Tamil Nadu, Assam, and Bihar. In jackfruit, both seed and flesh can be eatable. Production and utilization scenario of jackfruit. India is the highest producer of jackfruit, producing 1.4 million tons in 2021. Bangladesh leads in second, followed by Thailand, Indonesia, and Nepal. In Kerala, the annual production of jackfruit is 263,000 tons. Mostly 75% of the food produced in India goes to waste, because if we didn't properly preserve means it will go as waste. In case of jackfruit seed, it is often discarded as a waste, but it is also one of the valuable part in the jackfruit. And jackfruit seed consists of high fiber content and B complex vitamins. This fiber content reduce the risk of heart diseases and improve the digestion system. Currently, peeling the jackfruit seed coat is one of the time-consuming and laborious process, but with the use of seed peeler, we can reduce the processing time and it improve the product quality by reducing the risk of contamination during the peeling process. So an electrically operated jackfruit seed peeler was developed, in which the peeling was achieved by abrasion of seeds against the emery coated. But during the process, this emery stones are detached from the cylinder and it mixed with the seed coat, which reducing the quality of the final product. To overcome this product, in this study, we modified the existing machine with the perforated steel as the inner cylinder. So it is an alternative for emery coated. Objectives of the study are to determine various engineering properties of jackfruit seed, to fabricate electrically operated jackfruit seed peeler, and to evaluate the performance evaluation of the machine by using design expert software. Materials and methods. Engineering properties. Prior to the development of machine, the engineering properties of jackfruit seed was determined. The major engineering properties are density, true density, geometric, mean diameter, sphericity, coefficient of friction, and water activity. These are all the various equipments to measure the engineering properties: infrared moisture meter used for measuring the moisture content, and false bottom apparatus for coefficient of friction, water activity meter for water activity, and overhead projector for sphericity of the seed. Development of jackfruit peeler. These are all the components of jackfruit seed peeler: frame, outer cylinder, perforated inner cylinder, base plate with ring and bearing. This perforated inner cylinder is the actual modified part. Against this perforated cylinder only the abrasion taking place. Rotating disc with perforation. This rotating disc is attached to the connecting shaft, which gets the power from the motor through the belt and pulley. It rotates the rotating disc. Due to the rotation, centrifugal force is created and abrasion is taking place against the disc. Then motor is connected to the variable frequency device. This is the motor controller, which changing the frequency and voltage of power supply. The working of machine. First, the machine is plugged and the VFD is set to the required heads. Then the jackfruit seed is filled to the desired level. After the VFD is started, the rotating disc is rotated by getting the power from the rotating shaft. The shaft is attached to the motor. Through the belt and pulley, it gets the power. Due to the rotation of disc, the centrifugal force is created, which causes the abrasion of seeds against the perforated steel sheet. Then after this switch on, the peel seeds are manually removed. Then the peels can be washed down through the water outlet. These are the process parameters. Independent parameters are time and speed, and dependent parameters are seed damage, material loss, and peeling efficiency. Design of experiment. The To design the experiment, response surface methodology, software design expert version 12 was used. Here, two independent parameters are there, rotational speed and time. So 13 treatments were carried out as a part of experiment. Then stopwatch were used for measurement of time and VFD is used for varying the speed of the rotating disc. Optimization is done using RSM software, which is considering three dependent variables. Optimization was done to get the maximum peeling efficiency with minimum of seed damage and material loss. Resultant discussion. These are all the engineering properties. Properties range and average observed values. These are the fabricated images of fabricated jackfruit seed peeler. This is the output of the RSM software. Here we have to give the maximum and minimum limit of independent variables and it will optimize the parameter. Optimization, considering the maximum peeling efficiency and minimum material loss and seed damage, time and speed was optimized. The optimized time is 0.98 minute and speed is 39.99 hertz. The peeling efficiency was optimized at 97.85% and capacity of the machine was 22.5 kg per hour. This is the comparison between manual and mechanical peeling. The test was conducted with 22 seeds, almost of 7 grams of seeds. Cost economics, the cost of the developed jackfruit seed peeler was 43,250 and benefit cost ratio of the machine was 1.84:1. Coming to conclusion, we all knew manual peeling process include more time. It require more time. For reducing that processing time, we are developing the seed peeler for jackfruit seeds. The seed peeler mainly works on the principle of centrifugal force, abrasion, and impact. And the parameters were optimized. The optimized time is almost 1 minute, 0.98 minute, and speed of 39.99 hertz. Scope for development, changing the electrical motor with an increased output power and provision of easy product removal system. Here in our machine, we have to remove the peeled seed manually. If we give any removal system means it will be useful. So the references. Thank you.
Okay, Harita. Can you please go to your first slide? Yeah, this is part of your BTech project or MTech project? BTech project. Okay. So the title is Modification and Evaluation of Jackfruit Seed Peeler.
Yes.
Okay. So any earlier studies has been carried out?
Yes, ma'am. Before they developed one jackfruit seed peeler. In that, outer cylinder is coated with emery stones. Against that, rubbing action taking place. But during the operation, that emery coated is detached from the disc, so it mixed with the seeds. So it affects the byproduct quality. So what we did means we instead of that emery coat, one perforated cylinder we installed before that outer layer. So that the sheet is act as an inner cylinder. Against this peeling action was taking place.
So that is incorporated in this particular work.
Yes, ma'am.
Okay. So do you have any pictures of the final product? No, the efficiency you told it is 98, right?
Yes,
Peeling
ma'am,
efficiency.
98.7.
Peeling efficiency
Yes.
98%. Do you have any pictures of the final product?
Actually, I have one video, but it's
Okay,
not
yeah.
playing now. ma'am.
No, then it's okay. So also you have measured the various engineering properties which include density.
Yes, ma'am.
So what was the density? How did you measure? You didn't mention about the method.
Density mass by volume. Here we are considering the true density. Mass by the volume displaced, toluene volume displaced of that particular. If we added our mass of seed means how much volume is displayed. The
Okay.
ratio of mass and volume displaced by
So
using
that's a
that
standard
data.
method.
Yes, ma'am.
Okay. So did you find any sort of variation with regard to your raw material? How did you collect the raw material? From nearby?
Here.
Yeah. What was the normal range of density? I think you didn't mention that value in your slides.
In engineering properties, I mentioned.
Density is there?
Yes, ma'am. True density.
Yeah. Okay.
1.09.
Okay. 1.5, yeah. And what about porosity? 60.
Porosity is 56.55.
Okay, yeah. Okay, and what about the shelf life?
Shelf life. And we are not considering about shelf life, ma'am. But usually in manual peeling,
Only that like efficiency, peeling
efficiency
efficiency,
and
yeah,
reducing the damage of
material
seeds,
loss.
ma'am.
Okay, so what is your recommendation to control this particular material loss or damage loss? How can you uh, reduce that
Ma'am,
component?
here already it is 2% only seed loss, ma'am. But if we are already we optimize the speed, in further studies, if further trials will be done, if they reduce the speed means almost the loss will be reduced.
Okay, I asked some pictures because whether that brown peel also being removed, so
One,
or
I'll
only
check
that
that.
white layer is being removed.
White layer, ma'am.
Just to see that I asked that question. Okay, yeah, fine, thank you.
I had that video, but now it's not playing.
I hope I don't have much questions. I hope I just want to ask one thing, whether this can be whether we can reduce the cost of this equipment. You have told that 43,000.
Yes, ma'am.
So what is the scope of this jackfruit seed?
We can produce byproducts, jackfruit seed powder,
Huh.
and we can mix it with wheat powder for making chapatis and all. And it is act as a binding agent, ma'am, in food system.
So it has an ample
Yes,
opportunities.
ma'am.
Okay.
The main objective of this study is to, if some farmer have to produce more byproduct from the seed means, for manual peeling means it will require more time. If they have the seed peeler means we can reduce the time, so they can produce more volume of product. So it will increase the income of the farmer, ma'am.
I think more than farmer, I think it is useful for some self-help groups and all.
Self-help groups, small and medium scale entrepreneurs also, they can use this.
So I think you have to work on it to reduce the cost, and I think it's okay. Okay, good.
Hi, Harida, just a clarification. Do you know the cost benefit ratio of the previous model?
That I don't know, ma'am. Here
Okay.
it is 1.84:1, ma'am.
Okay,
Benefit percentage.
okay. What did you consider under cost aspect and benefit aspect? Just what properties you considered?
Ma'am, here the capacity of the machine is 22.5 kg per hour.
Okay.
So it will reduce the processing time. So it will, if they can produce more volume of byproduct, so it will increase the benefit, ma'am.
Okay, no. What did you consider under benefit?
Benefit in the sense,
You did the CBR analysis, right? You did it.
yes, ma'am. Cost analysis.
So in that benefit, you must have quantified or you have taken in some rupees or something.
Benefit based on the capacity of the machine only we decide on the benefit.
Capacity.
Yes, ma'am.
That is full capacity you considered.
Yes, ma'am. The capacity of the machine is increased means automatically we can produce more product. It will give more income for the farmers or who are using this. So it is also considered as benefit, ma'am.
Okay, fine. And this equipment, it will work efficiently even if it is half filled, half loaded?
Yes, ma'am. Actually, we did experiment with low number of seats only.
Okay.
Within that only, we can compare the manual and mechanical comparison.
Okay.
So it can produce, ma'am, because in downside, bottom side also that perforated disc was there. Inside also inner cylinder perforation is there. If less quantity also in bottom side and side, it will peel. So in less quantity also it will work.
It will give 98%
Yes.
efficiency. Okay, thank you.
Thank you.
And in the title, one more suggestion. Like in the title, you didn't mention about electrically operated or electric.
Yes, but it is
So
electrically
from
operated machine.
merely by seeing the title, you feel it's an evaluation of jackfruit seed peeler. We have different types of peelers available, right?
Yes, ma'am.
So what is the uniqueness of your particular product that you should highlight in your title?
Yes.
Okay.
Thank you.
Thank you. That was test number SC003. Next, I call upon test number SC008, which is an online presentation.
Anne, are you ready?
Am I audible, ma'am? Hello?
You are audible. You can start your presentation.
Good morning. Okay, ma'am. Good morning, one and all present in the online presentation. So, welcome to the national seminar. Here, I am presenting the topic development and performance evaluation of tender jackfruit peeler. And my members are Mukit Anil Kumar, Abhin Rag, Aman, Paisha K, and Dr. Rajesh GK. So, the contents of my presentation is introduction, materials and methods, results and discussion, summary and conclusions. So, we all know from 2018 onwards, jackfruit is considered as the official state fruit, and its scientific name is Artocarpus heterophyllus. And India is the largest producer of this jackfruit, followed by Bangladesh and Thailand. And the main consideration in this study is the tender jackfruit. So, tender jackfruit is the immature jackfruit which is harvested before when it reaches maturity. It is very nutritious and it contains many fiber, and the demand for value added products of tender jackfruit is increasing day by day. But we know the conventional method of peeling, that is the peeling of the jackfruit using a knife, is labor intensive operation and also results huge amount of peeling loss. So the effective mechanization of this process is the need of the hour. So the objectives of this study is to study the engineering properties of the tender jackfruit, to develop a mechanical tool for peeling of the tender jackfruit, and to evaluate the performance of this fabricated machine. So moving to the materials and methods. The tender jackfruit of Verca variety is harvested for this study is harvested from the instructional farm of KCT Tavanur. And for designing our machine, first we measure the engineering properties. It includes physical properties, that is fruit length, fruit diameter, rind thickness, and fruit mass. Let's look one by one. We are measuring the fruit length because we are fixing our jackfruit in between two circular discs. So for knowing the length of or distance between the for fixing the distance between the two circular discs, we have to know the fruit length. The fruit length is measured by maximum height measured from the top of the tender jackfruit to the bottom, and it is measured using ruler. Then we have to measure the fruit diameter. We have to know the fruit diameter because we want to design the circular disc based on the fruit diameter. So fruit diameter is the longest dimension perpendicular to the fruit length, and it is measured by measuring the circumference of tender jackfruit using measuring tape. And this diameter can be measured using the equation d is equal to c by pi, where d is the tender jackfruit diameter, and C is the tender jackfruit circumference. Next is fruit rind thickness. We are measuring the fruit rind thickness for designing our peeler blade. So the rind was removed manually from the jackfruit using a sharp knife, and its thickness was measured in centimeter using a digital caliper with accuracy of 0.01 mm, and the mean values were calculated. Then fruit mass we have to measure. Mass of the individual, based on that fruit mass, we are designing the capacity of our machine. So and we are taking the average value and design the machine. So mass of the individual fruit was determined with an electronic balance of 0.1 gram accuracy, and the mean values were calculated. Next, the development of tender jackfruit peeler. So this is the AutoCAD picture of our developed machine. So based on the preliminary studies, tender jackfruit peeler was developed. The working principle of peeling operation is such that we are fixing our jackfruit in between these two circular discs, and these two circular discs consisting of 4 blades, and we are piercing our jackfruit into these blades. So, and the operation is like that. The peeling was done helically due to the linear motion of the blade from the top to bottom. That is, we are fixing the jackfruit in between two discs, and here our blade. So the blade will move from top to bottom, and our jackfruit is rotating. So the peeling will takes place in a helically due to the linear motion, and the clearance between the blade and peeler arm was fixed on the basis of the thickness of the rind. So the major fabricated components of the machine is, one is fruit holder. These are the fruit holder, then peeler assembly, then power transmission unit, and the frame assembly. So first one is fruit holder. So this is the fruit holder. So this fruit holder is a disc shape, disc-like structure consisting of 4 blades on its surface. So it consisting of a disc and blade made up of food-grade stainless steel, and it was designed as a rotating disc that can carry the jackfruit on a horizontal plane. The dimensions of the disc were 1 centimeter thickness and 7.5 centimeter diameter. It was designed based on the diameter of our jackfruit, and the jackfruit was fixed on the disc by 4 blades to avoid the slippage between the fruit and circular disc. And this each projection was made with the dimension 0.9 centimeter height, 3 centimeter width, and 0.5 centimeter thickness. Then our peeler assembly. The peeler assembly consisting of screw shaft, then a peeler arm is there, then a blade for peeling, then a spring is attached to this for the easy peeling of this and tender jackfruit. So this is the pictorial representation. So this is the peeler arm assembly, screw shaft. Here blade spring is attached, and this is the peeler arm, and the blade is here, and it is attached in a rectangular housing here. So first component is screw shaft. So as to provide a linear motion to the peeler arm by rotating on its axis. That is the function of screw shaft. And it is made using MS rod with square threads on its surface. And its dimensions were length 64 centimeter, diameter 2.4 centimeter, and screw pitch 0.23 centimeter, thread width 0.15 centimeter, and thread height 0.15 centimeter. Then it was passed through the internal threaded circular passage of rectangular housing, and it is attached to the peeler arm. And the pulley, having a diameter of 26 centimeter, is made up of cast iron, was fixed on the bottom of the screw shaft to take the drive from the fruit holder shaft. Next is this is the peeler arm. So it was made using food grade SS304 stainless, having length 18.5 centimeter, width 2.6 centimeter, and thickness 0.5 centimeter. So for the effective peeling, the another end of this peeler arm was bent slightly at 35-degree angle, which supports the peeling blade. And the peeler was connected with a screw shaft. This peeler is connected with the screw shaft, which is moving parallel over the jackfruit profile, tender jackfruit profile. So the fruit was completely peeled from the bottom to top. Next component is spring. So the spring was attached between the peeler arm and the rectangular housing. So the major function of spring is to provide flexibility in the peeling operation, so that the cutting blade easily passes over the surface of the jackfruit. So the main function of the spring is to press the peeler arm softly over the jackfruit profile and holds the peeling blade in position against the jackfruit. Next is peeling blade. So this blade was made using SS304 steel, and the clearance of 1.2 centimeter between peeler arm and blade was fixed based on the rind thickness. Next is the power transmission unit. So it consisting of an electric motor, gearbox, and belt and pulley. So electric motor, we are using a 0.5 HP single phase reversible electric motor of 1425 RPM, and a speed reduction gearbox is there for connected with motor to reduce the speed from 5:1 RPM, and it consisting of a set of rotating gears, engine shaft, and propeller shaft. Next is belt and pulley. It was used to transmit power from one shaft to another. Next is frame assembly. So the main frame was fabricated from MS iron square channel for mounting fruit holder. Then peeler assembly and power transmission system. The length, width, and height of the main frame were 65 centimeters, 65 centimeter, 98 centimeter respectively. The peeler assembly, fruit holder, and electric motor were assembled on the main frame using nut and bolt. So these are the specifications of the developed tender jackfruit peeler. Next is the operational procedure. So for the operation, the fruit was placed on the fruit holder. Then while loading, the jackfruit was held vertically to stand on the fruit holder, and we have to correct the position. Then after loading the jackfruit, the fruit was tightly holding in vertical direction. Next is peeling operation. So the fruit holder was driven in a clockwise direction on a horizontal plane. Then as the fruit holder rotates, it enables the peeling blade to move parallel to the profile of the jackfruit rotational axis. The spring pressed the peeling blade softly on the fruit profile so that the fruit was completely peeled. Here comes the demonstration video. So this is the demonstration video. We are fixing the jackfruit in between these two circular discs, and rotating peeler is there.
Your time is over. You have to wind up in another 30 seconds.
Okay. So the performance evaluation of the developed machine was compared with the measuring the peeling efficiency, material loss, etc. So the overall peeling efficiency was highest in large size fruits for a speed of 100 RPM, whereas lowest for 86.5%. And time taken for the mechanical operation is 2.30 minutes per fruit, and cost benefit ratio is 2.3:1. Then these are the scope for future work. And here we took three kinds of fruit, that is large, medium, and small size fruits for our study. Thank you, sir.
Okay, thank you, Anne. It was a nice presentation. So please go to your results and discussion slides.
Okay, ma'am.
Please switch over to view mode.
Is it visible, ma'am?
Yeah, okay. Next one.
Performance evaluation, time of peeling, peeling efficiency, and material loss. So first one is time of peeling. Time of peeling is about 138 seconds for large, and for small 128 seconds. Next is peeling efficiency. For large, the peeling efficiency is higher, that is 93.1, and for small, it is 86.5. Then material loss is also large for large sample.
Okay, over.
Okay. We also compared with traditional method of peeling. And for traditional method, the time is 5.2 minutes per fruit for manual peeling. And for this mechanical peeling, 2.3 minutes. Over, ma'am.
Okay. So this is basically a batch-wise peeler, right?
A batch-wise peeler, ma'am.
So how can you convert it into a continuous one?
For continuous,
And for you told that the time required is like 2 minutes for small time required is in
2
seconds
minutes.
on seconds na
Seconds, not 2
128
minutes.
seconds.
For small.
For small one you need 2 minutes, right?
Yes, ma'am.
And
Yes.
for say suppose 5 or 6 jackfruit is there, you may require another. How much is required for that in between time required?
Time,
So placing another one holding and for that operation, then again changing that.
just 1 minute, ma'am, because before doing the operation, we have to cut the top and bottom portion because we are fixing it on a, we are fixing this jackfruit on top and circular disc. So we need a flat surface. So that is only operation we need, pre-operation we need. We have to cut the top portion and slightly top portion and bottom portion, and then we are fixing that
Okay.
because it is a conical like at end. Only 1 minute or two, 1 minute we need for the inner time.
Okay. So what about its CBR ratio? How do
It
you
is,
justify that?
ma'am,
How do you justify it?
this is the cost economics ratio. So for the fabrication cost is about 35,000 rupees, 35,000 comprising the material and fabrication cost. Total hourly operation is about rupees 150.86, and labor charge. By combining this, we find out this benefit cost ratio.
And finally, what are your recommendations to increase its efficiency from 85%? Currently, you have 85 also, right?
Yes, sir.
So what are your recommendations or suggestions to improve the efficiency of this particular equipment?
If you are providing a customizable knife tip to change the knife tip for effective peeling, we can use that. Or if you are providing a sensor like that, that is in this operation we have to switch off when the operation is over. If you are providing sensor like that, we can save the time and complete the entire peeling process and save the energy also. Somewhat material loss is happening because the surface of jackfruit is uneven. So if you are designing the knife, somewhat flesh loss will also be happen.
Okay. And did you
Okay.
find any practical difficulties in handling this product?
Stickiness,
Yeah. How did it affect the functioning of the machine?
that will affect because after every operation we have to just clean that knife and top and bottom motion we have to remove.
Yeah, that's why I asked the first question. Can you make it a
Okay.
continuous one?
Continuous one, it's slightly impossible, ma'am, because that
Okay.
stickiness nature.
Okay, thank you.
Thank you, ma'am.
Hi, Anne. I just have two clarifications.
Okay.
Tender jackfruit you have specified. Why?
Yes.
So why did you choose tender jackfruit?
Because this tender jackfruit have many application, ma'am. Its value-added products have many application. One thing that, then already in our department we developed a jackfruit peeler.
And is it applicable for the ripened ones?
Ripened because when it matured, there will be a core. So that for removing that core, we need an additional device. So already we designed a jackfruit peeler in our institution.
Okay. Okay. And this cost benefit ratio, it is about 2, which is very good for equipment. And
Yes, sir.
how long does it take to reach that 2? Do you have any idea?
That I want to check, ma'am.
Okay, because it's pretty good for an equipment, which is, I think, is still under development stage.
Yes, ma'am. Actually, this is the BTech project, and I guided this work, ma'am.
No, but it is good, but it will be even better if you can find out how long it will take to reach that level.
Okay, ma'am.
happen in 1 day or 2 day, but it will take few days of use.
Okay, ma'am.
Okay, otherwise it's a good concept. Thank you.
Okay. Okay, ma'am. Thank you.
And my question is, what about a browning? Browning in tender jackfruit after peeling.
After peeling, somewhat color change will occur. But if we put this tender jackfruit in that, actually that I didn't do the work, like we didn't concern about the browning. We just look after peeling, that only we did. If
No,
we
what I'm
want,
asking is, it will take some time. No, you told that 2 minutes for one jackfruit.
yes, ma'am.
So within that time, you have noticed a browning reaction.
No, not that much browning. We didn't notice, ma'am.
Okay. Okay.
Like
Thank you.
that, this is coming, ma'am.
View mode. Okay. Thank you.
Okay.
Thank you. Judges, please note that was chess number SG008. Next, I call upon chess number SG004.
A green good morning to one and all. So myself, I am Shankar. I am going to present my topic of development of portable force convective solar dryer with temperature and humidity controller. So it is estimated that the post-harvest losses in developing countries, that is about 30 to 40% of the total production. The quality and quantity of the agriculture produce depends upon the processing methods and storage facility. So drying is the one of the preservation and processing technique to reduce the moisture content by 10 to 20% to avoid the spoilage in the food. So renewable energy consumption has the advantage of reducing the conventional energy sources and pollution to achieve the sustainable development goals. So solar dryer is the best suitable approach and sustainable approach for rural works and for the processing community. Solar dry, by definition, solar dryers are the devices that use solar energy to dry substance, especially food. Coming to modern solar dryers, the modern solar dryers include in a different way that it includes photovoltaic cells with different circuits and electric circuits for making the drying process rapid and portable. Coming to the objectives, so to develop an efficient and economical dryer using solar energy, to make a portable force convective dryer, evaluate the performance of the dryer by using combined temperature and humidity sensor. Coming to the materials and method, so this is the components of the dryer. So the dryer consists of cladding material, temperature and humidity exhaust, solar panel, battery unit, sensor display, food tray and absorber plate. So this is the development of this particular dryer is to improve the performance of the dryer. In previous same design in the dryer of previous dryer, there was only a temperature sensor. So it is not suitable to remove the moisture inside the chamber. If we are loading excess material inside the chamber, so it will if moisture is increased means then more moisture will be removed. Then that one particular exhaust is not suitable for removing the entire moisture developed inside the chamber. So that purpose only. So the combined controller unit was introduced, and for that purpose, the whole dryer setup was reworked and repainted, and the cladding materials also changed. So this is the flow chart of the controller unit. So in bottom, we can see the overall view. The power is generated from solar panel. Then it goes to the battery unit. Then battery unit is connected to the display, and display is connected to the sensor and the exhaust fan. One is for temperature and one is for humidity. In previous design, there is no battery. Here, why we are giving battery means if we are using the solar energy, so sometimes we are not getting the full day solar radiation. Some clouds will come. So at that time, we need to use the power. So the battery setup will enhance the performance. So working of the controller, how the controller work for the temperature and humidity. If we are doing one particular product means there is a limit for temperature and humidity. Within the limit, we have to dry. So for control the temperature, we have to long press the plus button for 3 seconds. Then the temperature value will flashes. Then we have to long press for the minus button for 3 seconds. Then we have to fix the temperature. For the same way, we have to control the humidity. For factory resetting, we have to press the plus button of the both temperature and humidity inside same time. So it is not working. So this is the overall view of the dryer. So it is like a suitcase. So after that, it will change that. In the component view, we saw that picture. Then it will be changed that. So it is like a one suitcase and it's like a trolley. So we can easily handle the dryer. So it will be a portable one. So methods of evaluating solar dryer: determination of moisture content is calculated by dry basis and wet basis. And estimation of drying efficiency is calculated by this formula. Coming to the result and discussion, the evaluation of the portability. The main aim of the dryer design is to reduce the weight. So this is the different components and corresponding weight. The overall total weight is 17.362 kilogram. So it is one common man easily accessible this weight. So it will be a portable one, and it is like a suitcase. In bottom of the dryer, there is a universal wheel, so we can easily move one place to another place like a trolley. Performance evaluation of the dryer. The performance evaluation of the dryer is classified into two types. One is no load condition and load condition. In no load condition, the temperature and humidity control unit was disconnected in order to achieve the highest temperature. So the experiment was conducted in the last week of February from 9 to 4 each day. The critical parameters of the drying process like temperature, relative humidity were calculated based on the available solar radiation. During the test, the available energy was equal to the useful energy because there is no food was loaded in that chamber and there is no control unit was connected. So at no load condition, this is the overall data of temperature and humidity controller off mode, atmospheric temperature and dry temperature, atmospheric humidity, drier humidity, and corresponding solar radiation. So in this data, we can see that at 2 p.m. there is the highest temperature was achieved, lowest humidity was achieved with the corresponding solar radiation of 655 watt per meter square. So this is the graph variation of solar radiation temperature of the dryer and ambient air with the time of no load condition. So we can see the bottommost that is atmospheric temperature, that blue color, and the dryer temperature is orange color. We can see compared to atmospheric temperature, the dryer temperature was so much high with that respective solar radiation. In the same graph, this is a variation of dryer atmospheric temperature and relative humidity. So here, compared to atmospheric relative humidity, here the drier humidity was less than that. So at no load condition, that highest temperature was achieved, lowest humidity was achieved. Coming to the performance evaluation of the dryer at load condition. So drying performance using cut mango with sensible heat storage at the temperature of 40 to 80 degrees Celsius, relative humidity of 50 to 30 degrees, 30%. So we have to fix these temperature and relative humidity prior going to the drying in the controller unit. So moisture content of the cut mango, open solar drying and PFC solar drying. So here initial moisture and final moisture. So the final moisture removed in open solar drying is 55.34. In PFC solar dry it is 69.26. This is the overall data of mango drying with a sensible heat storage. So this is a drying curve of mango, moisture content versus time. So we can see compared to the open solar drying, the portable force convective solar drying achieved more drying. And coming to the drying rate versus time, in this curve also we can see compared to open drying, the curve is so much attractive compared to the open drying. So drying efficiency of mango, the drying efficiency was calculated with this formula that is estimated. It was estimated that 34% of the overall drying efficiency. And coming to the cost economic analysis, so the after calculating all these things, so rupees per kg is 9.33 in this particular dryer. Coming to the conclusion, the objective of portable force convective solar dryer were achieved through make it portable. The size reduction ratio is 5:1. We see that previous picture. So we are making the 5% into 1% and good performance, good drying rate compared to open solar drying, good efficiency for mango it's 34%, good economy 9.33 rupees per kg. These are the sum of reference. Thank you.
So please go to your first slide, title slide. It's development of portable force convective solar dryer. So how do you make it force convective?
Because we are fixing two exhaust fan. So if we are fixing the temperature and control. If we are fixing temperature 20 to 40 degrees Celsius, if we are fixing that relative humidity 30 to 50% means once we are loading in that product inside the chamber, if the sometimes the temperature is very less. If we are more loading means then temperature will reduce. Then if temperature is reduced to below 20 means automatically the controller will on. Then the respective temperature exhaust will on and it will exhaust the inside temperature. Then temperature comes to the 20 to 40 range. Same way in humidity also.
So you have a control based on that variation with regard to temperature.
Yes, before going drying, which product we are here, mango is dried. So for mango, we are fixing the temperature and humidity range.
Now you go to your results slide, results. Yeah, previous slide. Next one. Results title. Take that slide with the title results. Yeah, it should be results and
Yes.
discussion instead of, and conclusion should come under as the last slide.
Yes.
Okay. So what is the cost required for
The dryer.
This particular, yeah,
So the overall cost is 9,500 rupees.
including all those
All these things.
sensors and exhaust and
Yes,
all.
ma'am. All things.
So,
In
and
previous dryer, it was 7,500. So we are introducing new sensor. So the cost will, and battery setup also. In previous drying system, there is
what
no
about the
battery.
solar panel?
Yes, panel is already in existing. That is 2,000 rupees.
Okay. And how much quantity of cut mangoes were placed for the trials?
For this experiment, it is 1 kg, but we can extend up to 5 kg.
Have you analyzed the quality attributes of the final product after drying? What was the final moisture content?
Final moisture content of the mango is 17.08%.
Okay, yeah. So instead of mango, if you use some other product,
Yes, ma'am. Actually, we did
have it.
sweet potato and potato. So time permits, here I present only mango.
Okay, yeah, thank you.
Hi, Shankar. My first doubt is you have done sun drying and solar drying, and you reported
Yes.
sun drying gave moisture content 30 and the other one 17.
Yes.
Did it take the same amount of time? For sun drying, did you dry it from 9 to 4?
Yes, ma'am. Same time.
Same amount.
Time simultaneously, here sun drying and here portable foods
And
conducted.
then you got this
Yes.
result. Okay, then it is impressive. Another one I would like to mention is you have used solar panel.
Yes, ma'am.
And you mentioned that it is used when there is no sun, I mean cloudy days or something like that.
No, ma'am. We are using solar panel
Exclusively for the dryer.
exclusively for the operating the sensor and exhaust.
Okay.
So if one day we are doing morning, we are going to dry. So after 11 o'clock, there is no sunlight. So within that 3 hours, that solar panel generate one power that will be saved in the battery. So the battery will work up to the capacity of then it will going for the sensor and exhaust.
Okay, fine. So one suggestion, maybe you will have to consider the dust accumulation on the solar panel, because nowadays studies are considering dust accumulation, which will definitely reduce the efficiency of your panel.
Yes, ma'am.
So you can consider that. Otherwise, the work seems to be good. There are hundreds of solar dryers being developed all across the country. So you should make something innovative. The suitcase shape is definitely interesting.
So the main aim is a portable one.
Yes.
So we can easily handle everywhere. So it will be helpful for the rural works and small scale household workers for that.
Even for, up to 5 kg means we can use it in the domestic scale also.
But coming to the scope means we are just placing the product. So we have to improve the efficiency, means we have to blanching. Blanching will help. Coming to like potato and sweet potato and all, we have to give blanching. Then we can increase the efficiency. And the cladding material also, if we are changing different cladding material, we can see the different result. We are using only that is a polyethylene material.
Okay. To add to that, I mentioned dust accumulation on solar panel. Lot of work is being done. You can consider that also. It will definitely improve the efficiency of your equipment.
Yes, ma'am.
Thank you.
Thank you.
Actually, what I have to ask is, in this slide, you have shown that initial moisture while open sun drying is 86% and final is 31.
Yes,
Why did you stop at that 31%? Because we can't store, no, 31% is not.
Yes, ma'am. Actually, we can't stop, but here we are. Our experiment is 9 to 4. So that particular time, what we are achieving in open solar drying comparing to this type of solar dryer. So for comparison purpose only, we are taking this one.
Okay.
For quality attributes, we can't stop here.
So that duration is 9 to 4
9 to
that
4.
time.
Yes.
Regarding dried product, another important parameter is water activity.
Yes.
Have you measured it?
No, ma'am. Here only the performance of the dryer. How we can improve the performance. So next studies will
Yeah,
be
the product analysis also to be done. So that's why that 31%, that's not a good value
ma'am.
for the final product. You have to continue the next day also.
Yes, ma'am.
Yeah, okay, thank you.
Judges, please note that was test number SC004. Now I call upon test number SC005.
Good morning, all. Myself, Archana Ravindran, PhD scholar at ICR Indian Institute of Spices Research. So, this is a part of my PhD work entitled Antioxidant Property and Active Compound Degradation of Sambar Oleoresin Blend extracted from spice powder blend during storage. Authored by myself, Dr. E. Jayasri, Anis K, Sharadambal, and Alfia PV. Coming to the introduction, we all know that spices are the aromatic plant substances and they are indispensable in the culinary applications. So among the various forms of spices used, spice powder blend is the most commonly used form. But the disadvantages of using spice powder blend include low shelf life, moisture absorption upon storage, etc. So using oleoresin as a substitute to spice powder blend provide a better shelf life, more intense and consistent flavor profile, and reduced microbial contamination. Objectives of the research work include to develop the formulation of liquid spice blend for culinary applications and evaluate its quality, and to evaluate the shelf life of the developed liquid spice blend formulation. The methodology followed was, first one is the standardization of ratio of spices for spice powder blend. So these are the raw material that has been used to develop the samba powder that provide the for complete flavor and aroma of the normal samba powder that we use in our kitchen. So second one is the shelf life evaluation. So this is the experimental design that we have followed. 4 treatment were used. T1 is the oleoresin extracted from the ambient stored powder blend. T2 is the oleoresin extracted from the powder blend stored at refrigerated condition. T3 is the oleoresin stored at ambient condition, and T4 is the oleoresin stored at refrigerated condition. All these samples were stored for a period of 1 year, and the experimental design that we have followed is 2 factorial completely randomized design with the 3 replicates, and the software used for the statistical analysis was R software version 4.3.0. So this is the diagrammatical representation of the storage study carried out. As you can see, first one image shows the developed samba powder blend, and this was stored in the laminated pouches at both ambient and cold condition, and oleoresin was extracted at every 2 months. So here the powder stored at ambient condition is the T1, and the one stored at cold condition is the T2. And next one is the initially developed samba powder was used for the extraction of oleoresin, and this oleoresin was stored in a glass bottle in both cold and ambient condition. And this is the T3 and T4 respectively. So the various parameters studied included, under physical parameter, we have studied specific rotation and specific gravity. Under biochemical parameter, we have studied antioxidant activity, total phenol content, saponification value, peroxide value, and degradation study. And under microbial evaluation, both bacteria and fungus was studied. And specific rotation was studied using a polarimeter, specific gravity by gravimetric method, total phenol content by folding culture method, antioxidant activity by DPPH, saponification value by titration against ethanolic KOH, peroxide value by iodometric titration, and degradation study by HPLC and GCMS, and finally microbiological evaluation by Poplite method. And among the next one is the study of major active compound. And in the raw material used, the major active compound studied included capsaicin from red chili, linalool from coriander, curcumin from turmeric, piperine from black pepper, and cuminaldehyde from cumin, and last one is the alpha-pinene from curry leaves. So among these active compounds, curcumin, piperine, and capsaicin are the non-volatile compounds. So they were studied using HPLC, and volatile compounds included cuminaldehyde, linalool, and alpha-pinene, and this was studied using GCMS. Coming to the result, first one is the shelf life evaluation. So in the methodology, I have told that under physical parameters, specific gravity and specific rotation were the 2 parameters studied. So both storage condition and storage period had significant effect on specific gravity and specific rotation. Next one is the biochemical analysis. First one is the total phenol content, and next one is the IC50 value, antioxidant property. As in the case of similar to the case of physical parameter, both total phenol content and IC50 value was significantly affected by the storage condition and storage period. Next one is the saponification value and peroxide value. We know that saponification value is the amount of KOH that is required to saponify 1 gram of sample. So up to, though we found that the saponification value was increasing, but it is acceptable according to the FSSAI limit. The value we got was acceptable. And next one is the peroxide value. Up to 6 months, we found that the peroxide value was 0, but from 8 months onwards, it was found to be increasing. but that is also acceptable to the limit. Here also the storage condition and storage period significantly affected the saponification value and peroxide value. And moving on to the study of active compounds, first one is the capsaicin content. First diagram shows the standard curve of capsaicin, and next one is the graph that shows the degradation of capsaicin in the oleoresin. Here also storage condition and storage period non-significantly affected the capsaicin content. Next one is the curcumin. As in the case of capsaicin, in the curcumin content was also non-significantly affected by the storage condition and storage period. And in the case of piperine also, storage condition and storage period significantly affected the piperine content. Next one is the evaluation of volatile compounds by GCMS. I have told that 3 compounds studied included alpha-pinene, linalool, and cuminaldehyde. This is the standard graph that shows the standard of cuminaldehyde, linalool, and alpha-pinene. So first graph shows the content of cuminaldehyde in the oleoresin upon storage. Cuminaldehyde content was significantly affected by the storage condition and storage period, and same in the case of linalool. That was also in the case of linalool, storage condition and storage period non-significantly affected the linalool content. And when it comes to alpha-pinene, storage condition non-significantly affected the alpha-pinene, whereas storage period significantly affected the alpha-pinene content. Coming to the microbiological evaluation, this is the images that shows the growth of organism in the oleoresin at 0th day. We couldn't find any growth. And this is the plates that shows the growth of a microorganism in T1, T2, T3, and T4 in 2nd month, 4th month. And this is 6th and 8th month. This is 10th and 12th month. Even after the completion of storage period, we couldn't find any growth of fungus or bacteria in any plates. Coming to the conclusion, spice powder blend was developed and oleoresin was extracted from the developed powder blend. During the storage of stored and extracted oleoresin, there was no change in physical parameters like specific rotation, specific gravity up to 12 months. And biochemical parameters such as total phenol content and antioxidant activity was found to decrease towards the end of storage, and no traces of peroxides was observed in the oleoresin till the end of 6 months, but it ranged from 1.5 to 3 milli-equivalent peroxide towards the end of storage. Results also indicated that saponification value and peroxide values are within the acceptable limit as per FSSAI. So active compounds such as capsaicin, curcumin, and piperine was found to degrade towards the end of storage, and maximum retention of 67% was found for piperine in the treatment T4. Among volatile compounds such as cuminaldehyde, linalool, and alpha-pinene, cuminaldehyde retained the most in the treatment T1. Irrespective of storage condition, all the 4 treatments were found to be microbiologically stable, and study concluded that the oleoresin from the powder blend stored or extracted oleoresin stored, though degraded during storage, it was found that the peroxide values of all the 4 oleoresin were within the acceptable limits, and hence could be considered safe for consumption. So thus, thank Director ICR IASR Kozhikode and Director of Research at Kerala University of Fisheries and Ocean Studies. Thank you.
So Archana, that was a nice presentation. So what is your major research finding of this particular study?
If you are extracting oleoresin and storing, we can extend the storage when compared to the powder that we store. Usually the curry powders have only 6 months of expiry date is like shelf life is 6 months, but this can be extended if you are converting it into a oleoresin. If you are storing it as an oleoresin, we can extend the shelf life.
So how does it help the normal people, normal consumers?
Yes, ma'am. Instead of adding curry powders, like if you are preparing a sambar, chicken curry, anything, we have to add curry powder like 2 to 3 teaspoons. So instead of that, all we have to do is just add 2 to 3 drops of this oleoresin so that we get the complete taste and aroma of the normal curries that we prepare using curry powders.
So what are the requirements for proper storage of this oleoresin extract?
Requirement in the sense how we have to
Yeah,
it can be stored in the glass bottle, ma'am.
Okay, is it readily available? Is it readily available in the market? Yeah.
No, it's not available, ma'am.
Yeah, so
my study is that.
so how will you what are your suggestions for outreach in the market? No, this is your research finding, na? You're telling that this instead of like blends, you have to use oleoresin extract. So is it readily available for the consumers? That's not the question.
As of now, it is not available in the market. So once my study is complete, once my PhD is complete, we will try to make it available in the market.
And what will be the smallest form in ml?
Minimum quantity.
Yeah, minimum quantity.
Regarding
Did
the
you think of?
packaging,
Did you think of any?
yeah, it can be started from 5 ml.
And what will be the cost?
Cost we haven't discussed, ma'am. This we just now
And what
completed-
about the packing? Packing will be in glass bottles only.
I just completed my study. It was 1 year of storage, right? So we haven't discussed regarding the packaging, like how it will be available in the market.
Okay, and you mentioned one parameter as specific rotation.
Yes, ma'am.
So how do you define it? Specific rotation.
Define it.
Go to the last slide. Conclusion. You have measured the various properties like specific rotation and specific gravity. Yeah. Physical parameters, namely specific rotation. Second bullet. Please go through that.
A specific gravity rotation was studied using polarimeter.
Okay.
Like equipment, digital value will be available in that equipment.
So what is its effect on the product?
Actually, both physical parameters were not changing upon storage. It was almost same now. Like in
Okay.
all the treatment, it was same.
Okay, thank you.
Hi, Archana. Archana, you have stored the sambar mix, the powder, masala mix for 12 months. And oleoresins also, extracted oleoresins for 12 months.
Yes, ma'am.
And both the sets, the powders as well as oleoresins, didn't show any microbial growth up to 12 months.
No, ma'am.
Then what
Like,
is...
Actually, in the oleoresin, this microorganism cannot sustain. Maybe during extraction that will
Exactly. That's what you don't have to be surprised if you don't get any microbial growth in
not.
oleoresin.
As it is a storage study, we have to show all the parameters.
Yes, agree. But then in powder also there is no microbial growth.
I haven't shown the result of powder, ma'am. The powder,
That's
there
what I
is
asked.
growth. That is after 10th month growth was found.
So up
That
to
was
10
also-
month, it was perfectly
Yeah, but
okay.
we extract oleoresin from that powder that is contaminated. We cannot find any microbes in the oleoresin. That's the beauty of this work, ma'am.
Exactly. That I didn't see. That's why I asked you, what about the
Growth
masalas?
was there in the powder, like towards the end of storage. After 10th month, we could find the growth.
Almost it is same. One is showing 10 months and oleoresins will definitely go beyond 12 months, no doubt. So that
We
is
couldn't
also...
find any bacterial growth, only fungus was.
Okay. Another point I would like to know, you have analyzed the oleoresins from the masalas. Every 2 months you have taken the oleoresins and checked it. So what did you understand? Is there any change in composition?
Up to 12 months, there is no any degradation, no much degradation.
Means the masala will give you the same flavor, everything will be same, right?
Almost same, almost all the parameters will be same. But compared to the powder, we can store this oleoresin for more periods.
Okay, so that is the highlight of your work, shelf life. But again, I beg to differ that we add masalas for the sensory, the appeal also, the color, appearance. We are getting?
But if we add powder, the curry will be more thick, right? Like if we add curry powder, samba powder,
Sensory.
We will get more thick samba. But if we are adding oleoresin, the curry will be little
Yes,
more
exact.
consistency. But ma'am, like Indomie and like Maggi,
Yeah.
we are getting it's like a sachet, right?
Yes.
Oil will be there, masala will be there along with the Maggi. So we are planning to market it like that. So those who want thick sambar, they can add sachet, like the thickness will be added in the packet.
Okay.
So those who are interested in thick sambar, they can add that sachet. Those who need the loose consistency can use for yours.
Okay, then it is fine. I think all in some of the Maggi type of products, I don't remember the name, they have liquid masalas coming in sachets. So if you have tried that and if you have found it is giving acceptance somewhat similar to sambar by adding few drops of oleoresin, then it is a good innovation. Thank you.
Judges, please note that was test number SG005. Our next participant is test number SG009.
009, online, last round. Zero, 009.
Ashita? Ashita? Is it audible?
Ashita, are you there?
Admit ആയില്ലേ? ഹലോ അർഷിത ജോയിൻ ചെയ്തോ? അഡ്മിറ്റ് ചെയ്ത് സ്റ്റാർട്ട് ചെയ്തോ? ഷെയർ ചെയ്തോ?
Good morning, Ashita.
നമുക്ക് നെക്സ്റ്റ് വയ്ക്കാം. അർഷിത is present.
Hello, ഞാൻ വിസിബിൾ ആണ്. ഹലോ ഹലോ
Ashita, start your presentation. Can you hear me?
ഹലോ
Can you hear me?
ഹലോ മാം.
Yeah. You may please start your presentation. The view mode. You have to switch over to view mode.
Hello, ma'am. Hello, ma'am. Bluetooth off है, not capable. Hello, ma'am. കേൾക്കുന്നുണ്ടോ? ഫോൺ ചെയ്യും ചേച്ചീനെ ചേച്ചി ഷെയർ ചെയ്തിട്ടുണ്ട്. ഷെയർ ചെയ്ത് കാണിക്കുന്നു. ഒന്ന് അവൾ പറയുന്നത് കേൾക്കുന്നുണ്ടോ? ഹലോ കേൾക്കുന്നുണ്ടോ? ഹലോ സ്ലൈഡ് ഒന്ന് ഓപ്പൺ ചെയ്യാം. സ്ലൈഡ് ഓപ്പൺ ചെയ്യാം. പ്രസന്റേഷൻ ഇപ്പൊ കാണുന്നുണ്ടോ? ഇപ്പൊ കാണുന്നുണ്ടോ ചേച്ചി? ഹലോ
Yes.
ഹലോ മാം.
Yeah, please start your presentation.
So, good afternoon to all. I'm Ashtar Thomas, and I'm here to take the national seminar on the topic development of a cocoa bean sheller cum vinola. So, cocoa bean, its scientific name is known as Theobroma cocoa, and it belongs to the family Malvaceae. So, this cocoa is also known as the foot of God, and the Indian variety of the cocoa is known as Forastero. And the cocoa is mainly grown in the tropical perennial region and mainly near to the equator. Primary cocoa growing regions are Africa, Asia, and Latin America. So this cocoa is having many uses and benefits, such as it is mainly used for the production of candle, ointments, pharmaceutical products, and cosmetics. And we can obtain cocoa powder and cocoa butter from these beans. And also it lowers chance of heart disease and also lowers the blood pressure. So the main processing of cocoa beans are, first we have to break the pod, then to undergo fermentation, drying, roasting, shelling and winnowing, and finally packing and storage. So why we need shelling of cocoa means the shell portion of the cocoa contains theobromine and it will affect the flavor and purity of cocoa nibs, and the shells and nibs should not be in a powdered form, because when it is in powdered form it's very difficult to separate them. Then winnowing of cocoa. Earlier it was being done by manually, but this mechanical winnowing is preferred because it improves the quality of cocoa nibs, and separation is mainly based on the difference in size and density, and it is combined with a small airstream. So the main objectives were to study the engineering properties of roasted cocoa bean and also to develop a continuous cocoa bean sheller cum vinola, Then performance evaluation of developed machine in terms of capacity, shelling efficiency, cleaning efficiency, and energy requirement. The major properties that coming under engineering measures are moisture content, which was measured using infrared method, and size and shape measured using vernier caliper, mass using electronic balance, true and bulk density using tapping method, color using colorflex colorimeter, then angle of repose using funnel apparatus, and then coefficient of friction. So the first model developed was consists of a feed hopper at the top, then below there is a roller mechanism and a concave mechanism, finally motor and frame assembly. So the main disadvantages were were having a shelling efficiency of 82% and the development cost around 12,000 rupees. Then final model of Cocoa Bean sheller, it consists of a feed hopper, metallic rollers, tube, motor and frame assembly. So the first one, top portion, there is a feed hopper. This feed hopper is rectangular in shape and it is mounted over the roller assembly, and it is made of 2 mm thick mild steel sheet. And below the feeder there is metallic rollers. These metallic rollers are mainly enclosed in the concentric cylinder, and there are a pair of ribbed rollers which are rotating horizontally, mainly in opposite direction. So these rollers are having 12 straight ribbed strips mounted on the shaft, and inside the roller there is a shaft which is having a diameter of 2.5 centimeter, and the roller diameter is 5.6 centimeter. Below there is a tube through which we can get the mixture of these cocoa nibs and shell, and this is made of 2 mm thick mild steel sheet. Then there is an electric motor which is used to work this machine. It is having a power of 0.5 HP with a speed of 145 RPM. Then frame assembly. So this feed hamper, roller, shooter, etc. are mounted on the frame. Then operational procedure. First we are taking the roasted cocoa bean and it is fed to the feed hopper. Then the intermeshed rotating rollers below the feed hopper is receiving these roasted beans, and the mixture of cocoa nibs and broken shells are collected in the tube. And after collecting this mixture, we are feeding it to the specific gravity separator. Then winnowing action, that is there are two vertical and horizontal stratification is there. Through the deck motion and gravity continuous separation, we are separating the cocoa nibs and the shell. Then there are mainly three openings where through one opening we can collect the nibs alone, and to one opening we can collect the shell alone, and the intermediate particles are from the middle opening. So in this diagram, we can see the mixture is fed through the top portion, that is the feed hopper, and we can control the deck movement and airflow controller through the bottom. There are two sections through which we can control the motion. The performance evaluation of the sheller, its capacity is around 155 kg per hour, and the shelling efficiency around 96%. The time required for the operation is 28 seconds, and cost of operation 76.30 per hour. Then performance evaluation of the winnover, cleaning efficiency 89.38%, and time required is 2 minutes. Then coming to the result and discussion, the engineering properties of the roasted cocoa beans were measured, like the average moisture content were 5.3, length, width and thickness were 25.12, 13.92 and 7.87, geometric mean diameter were 14.55, viscosity 0.55, true density, bulk density. Then color was measured, that is L, A and B values. Then coefficient of friction on aluminum is 0.20, galvanized iron is 0.30, and plywood is 0.40. Then angle of weight was around 22.37. Capacity of the sheller is 155 kg per hour. Then the percentage effective shelling was found to be 96.04%, and the percentage of uncracked bean was found to be 3.95%. So after this project, the final conclusion was the major purpose is to give this machine to the small scale farmers, so it will be easy processing for them. And the constructed machine has paved a path to lift the processing of cocoa to an easier level, which is accessible to any local farmer who runs a small scale unit. So further scope is that we can combine this shelling and winnowing machine together, so it will become a continuous operation, and the feed given into this sheller section is subjected to a controlled action which avoids the chances of overloading of the cocoa beans and jamming of the rollers. So these were the references. Thank you.
Thank you, Rishita.
Thank you.
So, do you have any pictures of the cocoa dry, which is being cocoa bean sheller cum winnower, which was developed by your project?
Yes, ma'am.
No, that's a schematic, na?
This is the image, ma'am.
Okay. So what is the capacity of this one? 155 kg.
Kg per hour.
So it's a continuous process.
Yes, ma'am.
Okay. So what is the mechanism used for winnowing?
Winnowing, we are separating it based on the size, shape, density. That is, the lighter particles will float and the components will be settling, and through the three openings we can collect them.
Yeah. So what are the parameters that will affect the efficiency of this particular equipment?
Efficiency, ma'am.
What are the parameters which will affect the efficiency?
And this,
You told
sometimes
that you have 96% efficiency, right?
yes, ma'am. So when these components will be in a broken state, but through winnowing action we are separating means in one outlet we are getting the nibs alone, and in one outlet we are getting the shell. So there is a high efficiency.
Okay. What is the cost of cocoa beans? Market value, any idea? Okay, thank you.
My question is, so what is the benefit of your cocoa bean sheller cum winnower? What are the benefits?
Benefits means, ma'am, this we need to remove the shell portion because it is containing the theobromine content and it is having a poisoning effect. So therefore we need to shell, and if the shell is present along with the nucleins, it will affect the purity and
Your
the flavor
voice is
also.
not audible, not clear actually.
Ma'am, hello, hello, ma'am.
Once again, can you explain? There is no clarity. You are saying, but it's not clear to us.
Hello, ma'am. Hello, ma'am. Is it audible? Hello, ma'am.
Hello?
Ma'am, is it audible?
Once again, you repeat once again.
Ma'am, this anyway for the processing we need to get the cocoa nibs along, and this shell portion of the cocoa is having a high range of theobromine content. So in order to remove this, we are going for this sheller cum winnower.
Okay.
Ashita, I just have one clarification. There are some properties mentioned under coefficient of friction. SS, GI. What are these?
Ma'am, we are means in
Maybe slide number 23. I saw second time. And before that also you have mentioned. Slide number 23.
yes, ma'am. We are measuring the engineering properties of
Coefficient of
this.
friction. Yeah.
Yes, ma'am. Coefficient of friction. That is, we are placing the beams along steel, aluminium, and galvanized iron
Okay,
plywood.
different material.
Okay, ma'am. We are placing these
Okay.
beams along the surfaces.
Okay, got it. Thank you. Yeah, that's it. Thank you.
Thank you, ma'am.
Judges, please note that was chest number SG009. Next, I call upon chest number SC006.
Good afternoon all. Myself Meera Mohan, first year research scholar at IASR. We registered a course in the Department of Food Science and Technology. This is a small part of my PhD work entitled Antioxidant and Physicochemical Characterization of Co-crystallized Jaggery Cubes Blended with Ginger Oleoresin, authored by myself, Dr. E. Jayashree, Dr. K. Anis, and Ms. Alfia PV. That's about the introduction part. The non-centrifugal sugar, which is prepared by concentrating sugarcane juice, is commonly known as jaggery. The beneficial health properties of jaggery, which makes it to be used as a dietary substitute to white sugar. The nutraceutical properties of jaggery, it can be improved by blending and fortifying it with medicinally important spices, which would not only enhances the nutritional properties, but it will also offer value-added products with exciting flavors for the tabletop use of sweeteners. The technology of co-crystallization encapsulation with sucrose as raw material, which is used for this purpose. Here the spice which I have taken is what? Ginger. Ginger rhizome. It is used as a food as well as a spice due to its characteristics, flavor and pungency. Traditionally, the flavored jaggery cubes which were prepared using concentrating sugarcane juice and blending it with dried ginger powder. But in the present study, liquid jaggery, which was an intermediate product during the processing of jaggery, which was selected as the raw material instead of sugarcane juice, then ginger oleoresin, which contains both the aromatic as well as the pungent principle in a concentrated form, which is used instead of traditionally used dried ginger powder. The objectives of this study were as follows: to optimize the concentration of ginger oleoresin and emulsifier for the preparation of ginger flavored jaggery cubes, and to study the antioxidant and physicochemical characterization of this jaggery cubes. Then about the materials and methods. Liquid jaggery with GI tag, which is purchased from Marayur. GI means geographical indication. Then the ginger oleoresin with 28% gingerol, which was purchased from Plant Lipids Private Limited, Cochin. Then gum acacia, it's a common food additive which is used as an emulsifier, which is purchased from High Media Laboratories. Then about the manufacturing process. First, the liquid jaggery, which is a raw material, which will be concentrated in an open pan with continuous agitation. Then temperature should be monitored continuously. After some time, we can see a sand-like turbidity inside the walls of that container, which indicates that it is the starting point of crystallization. So here the co-crystallization process occurs. At that stage, we have to add the ginger oleoresin in an emulsified form. We can't directly add this ginger oleoresin, so it should be emulsified using a permitted emulsifier. It's an all-purpose food additive. That is what gum acacia, which is obtained from plant exudate. So it is permitted to use in foodstuffs. So this emulsified ginger oleoresin, which will be added at the beginning of this crystallization process. So in the co-crystallization process, the sucrose, the regular crystalline structure of sucrose, which will be open ups. So it will creates an open matrix for the this active ingredient to be incorporated. At that point, we have to add this emulsified ginger oleoresin. So then the spontaneous crystallization occurs. Then the semi-solid mass which obtained, which will be transferred into silicone mold with a cube size of around 15 to 15 millimeter. Then the product get cooled to 45 degrees Celsius and it can be packed in suitable packaging material. Then the quality parameters which were evaluated for this study was total phenolic content by Folin-Calcium method, then the antioxidant property by DPPH radical activity method, sucrose, which is one of the major ingredient which was present in jaggery, which was evaluated by the common Leyland-Heinen method, protein by Lowry's method. Then about the moisture content, hygroscopicity, water absorption index, water solubility percentage, bulk density, that physical parameters can be evaluated by the following equations. Then the hardness, it is a major factor for this Jaggery cubes. It will be evaluated using the texture analyzer. Then the overall acceptability of that final product, which will be evaluated using 9-point hedonic rating test. Then about the experimental design, the concentration level of ginger oleoresin, which starts from 0% to 0.4%. Then the concentration level of emulsifier, which starts from 0% to 3%. 3 replications were made, and the statistical design was 2-factor completely randomized design. The statistics was R software 4.3.0 version. Then about the results and discussion. From the graph, it is clear that the total phenolic content as well as the antioxidant activity of ginger flavored Jaggery cubes, which were increased significantly with the increase in concentration of gum acacia and oleoresin. Then about the sucrose content. The sucrose content of the flavored Jaggery cubes, which remains constant by the addition of this gum acacia as well as oleoresin. So the concentration of gum acacia and oleoresin having non-significant effect on the sucrose content of the flavored Jaggery cubes. Then the protein content of the flavored Jaggery cubes, which were increased significantly with the increase in concentration of gum acacia as well as oleoresin. Then about the moisture content. The moisture content of this flavored Jaggery cubes, which were reduced significantly with the increase in concentration of gum acacia and oleoresin. Then the hygroscopicity percentage of the flavored Jaggery cubes, which were decreased significantly with the increase in concentration of gum acacia, but the concentration of oleoresin having non-significant effect on the hygroscopicity of the flavored Jaggery cubes. Next, about the water absorption index and water solubility percentage. From the graph, it is clear that the water absorption index of the flavored Jaggery cubes decreased significantly with the increase in concentration of gum acacia. Then about the water solubility percentage, which is increased significantly with the increase in concentration of gum acacia and oleoresin. The interaction between gum acacia and oleoresin having also a significant effect on the water solubility percentage. The bulk density as well as the hardness of the flavored Jaggery cubes, which were increased significantly with the increase in concentration of gum acacia and oleoresin. The interaction between ginger oleoresin and gum acacia having significant effect on the bulk density as well as hardness of the flavored Jaggery cubes. The overall acceptability of the flavored Jaggery cubes were increased significantly with the increase in concentration of gum acacia and oleoresin. Then about the summary and conclusion, the results of sensory evaluation indicated that the overall acceptability was highest for the flavored Jaggery cubes prepared with 2% gum acacia having 0.3% ginger oleoresin. The moisture content of the optimized cubes was 7.33% and was found to be decreased significantly with the increase in concentration of ginger oleoresin and emulsifier. No change in sucrose content and the value remained constant at 80.09%. The total phenolic content for optimized sample was 343 milligram per 100 gram having IC50 value of 5.77 milligram per ml, which indicates that the total phenolic content as well as the antioxidant property of ginger oleoresin blended Jaggery cubes were significantly higher than the non-blended Jaggery cubes having total phenolic content of 198 milligram per 100 gram and IC50 value of 7.79 milligram per ml. The authors thank the director, ICR IASR, Kozhikode, and the director of research, Kerala University of Fisheries and Ocean Studies, Kochi. Thank you all for this opportunity. Thank you.
So Meera, that was a nice presentation. So this work was carried out at the IASR. Okay, and all those crystallization process and all that done there only. Raw material collection. Please use your mic.
Jaggery cubes, he was preparing it with dried ginger powder, then it will get broken during processing and all. So he came to us, and so instead of this dried ginger powder, we added ginger oleoresin. Along with that, in order to improve the hardness of that product, we were added gum acacia. It acts as an emulsifier as well as a stabilizer and thickener. It's a multi-purpose food additive. So we can improve that thickness and all. Then he was ready to purchase that product from us. Likewise, we did.
So you have a buyer with you.
Yes, ma'am.
So the product is now available in market, is it?
No, ma'am, not yet. The different process were going on. Ma'am.
Okay. So what about all that good manufacturing process?
Everything we have to discuss, ma'am. We just started in January only, ma'am. Then the discussions are going on. He evaluated the product and he was happy with the product. So the processing steps were going on.
So what is your role in this particular project?
Ma'am, actually my PhD topic, which will be selected during that time, co-crystallization I have selected. So in the initial time, I have selected with sucrose. That is actually which will be added for the co-crystallization process. Sucrose, which is added as a raw material. So during the study, that buyer came. Then I studied about the why we can incorporate sucrose, which is also an important ingredient in jaggery also. So it will add more effects. If we use this sugar cubes by blending this ginger oleoresin, this total phenolic content, antioxidant, everything will not be available there. But if you use this jaggery instead of sugar, we can add more values to that. So likewise, we got.
Crystallization is an important.
It's an co-crystallization. That's my research topic is regarding different encapsulation technologies. This is one of the encapsulation technologies. 2 more technologies will be selected.
So you are incorporating gum acacia.
Sucrose, it will act as a raw material. Along with that, we can add gum acacia for thickening purpose and all.
So by varying that percentage, different levels, how does it affect that crystallization?
Yes, ma'am. It will affect that crystallization. It will mainly affect the crystallization. Actually, that gum acacia addition, which will mainly affect the hardness of that product. That is the main issue. Solubility. Yes, it will broken down easily. But when we add this gum acacia, we can make it in a hardened form. So we can add this cubes, 2 to 3 cubes in a glass of water. We will get that flavored. Glass of tea or coffee, we will get that flavored tea.
So how much time will be required? Just out of curiosity, I am asking.
Yes, ma'am. How much time to prepare this cubes? Or
no, solubility for dissolving that cubes.
Within seconds, it will dissolve.
No, the other way. Now we are having different products like jaggery powder and all. Instead of that solid, we are converting it into powder. And here you are trying.
Yes, ma'am.
Cubes, so it should be readily dissolvable.
Yes, ma'am. It is readily dissolvable. That cubes, 1 or 2 cubes, we can put in hot water. It will dissolve. Then it will give that flavor. I am trying with cumin, cardamom. Everything is there. I have taken only one part here.
Okay, good. All the best.
Thank you, madam.
Actually, it's a good idea during cold and fever. No.
Yes, ma'am.
Like what we are getting from that Eastern.
Yes.
Means, Chukku kapi.
Everywhere they were adding dried products, ma'am. Here we instead of that we added this oleoresin, so it makes some difference, ma'am.
Okay, then what about the shelf life?
Shelf life commonly we will get about around 6 months for this one. I have to take trying to take it to
at room temperature
at room temperature itself, ma'am. So moisture content is around 5 to 7%, so we can store it in room temperature itself. Likewise.
Okay, thank you.
Thank you, ma'am.
Hi, Meera. Nice concept.
Hello, ma'am.
Meera, I have a doubt. When you hold it in the hand,
Yes, ma'am.
does it show some melting property or?
For a long time.
Not a long time, maybe 5 minutes?
No, ma'am. No issues.
No,
No
means
issues
it is,
with that. No issues with
it is having good stability.
that. Yes, ma'am.
But still, since from a research point of view,
Yes, ma'am.
it will be better if you can study the crystallization characteristic, do some XRD or something, learn something
Okay, ma'am.
about.
That I will find.
And you have not optimized the optimum level of the gum emulsifier, right?
Yes, ma'am. That is 2%.
2%. Okay, that is in somewhere in
optimized.
between, I think. Of the,
Pardon, ma'am?
what was the range that you took?
0 to 3%.
So this two comes somewhere in between.
Yes, ma'am.
Okay, fine. Yeah, that's it.
Thank you.
Thank you.
Thank you.
Thank you. That was test number
Excuse
SC00.
One more question. Have you done any cost analysis? Cost analysis.
That was test number SZ006. Now I call upon next participant, test number SZ007.
A very good afternoon to one and all present here. Today I am here to present you on the topic formulation of herbal tea from Punica granatum peel powder. So, the fruits and vegetable industry produces a large amount of waste, which is almost around 20 to 30%. In case of pomegranate, peels are the major byproducts that are produced during its processing. In this recent scenario, the peels of pomegranates are getting much attention due to its confirmed therapeutic properties like antimicrobial, anti-cancer, anti-ulcer, and anti-inflammatory properties. And also, so by preparing a herbal tea with the incorporation of pomegranate peel would gradually increase the functional properties of the herbal tea. Moisture content analysis is an important factor in determining the freshness and quality of the product. So, our objective is to produce or prepare or investigate the suitability of pomegranate peel for the formulation of value-added herbal tea. And we are conducting a sensory evaluation based on 9-point hedonic scale. And the moisture content of the selected tea blend is evaluated. So these are the materials we require for our project: pomegranate peel, cardamom, basil leaves, cinnamon, clove, and ginger. So coming to the methodology, the pomegranate peel along with the herbal ingredients are collected and cleaned. The peel is cut into smaller pieces and it is tray-dried in tray oven for 70 degrees Celsius, and the herbal ingredients were dried in tray oven for 45 degrees Celsius. These dried materials are then grounded to fine powder. It is filled in the tea bag, weighing approximately around 3 grams in each bag. And also the sensory evaluation of the tea bag and the moisture content determination was done. The sensory evaluation was based on 5 panelists: women, healthy, non-smoker, and aged between 20 and 50 years. Samples were given based on the codes given below, and also taste, flavor, color, appearance, and overall acceptability of each blend was analyzed. So these were the 3 batches we given for the sensory evaluation, varying the constants of various peel and also the herbal ingredients. The moisture content analysis was dried in hot air oven at 105 degrees Celsius for 12 hours. It was based on the equation W1 minus W2 by W into 100. W1 is the initial weight of the sample along with the dish. W2 is the final weight of the sample and dish, and W is the original weight of the sample. So coming to the results, after the sensory evaluation, the sample T2 had the maximum overall acceptability, and it had a concentration of peel about 0.6 gram. For the moisture content determination, the moisture content of the sample was turned out to be 8.33%. So, for the conclusions, herbal tea was prepared from pomegranate peel and other ingredients, and the moisture content was of the selected blend was observed to be 8.33 percentile. So, therefore, a herbal tea prepared with pomegranate peel and herbal ingredients act as a better alternative for very health concerned people, and also it helps in maintaining a sustainable environment by reducing wastage. So, as of now, there is no commercially available pomegranate herbal tea. More shelf life analysis are being done. If you could complete it, we will be happy to introduce a new marketable product. Thank you.
Thank you, Angel. So you told that it is a herbal tea. So why you are calling it as a herbal tea?
Mainly because of its ingredients, mainly herbal ingredients like cinnamon, cardamom. It has many medicinal benefits, so it is being used.
Then what is additional benefit of this herbal tea while adding pomegranate peel powder?
Pomegranate peel is very much rich in antioxidant, anti-inflammatory, anti-cancer properties. If we could incorporate this, it adds to the functional property of the herbal tea.
Whether you have studied any nutritional quality analysis, whether...
Ma'am, we have conducted phytochemical analysis for phenols, but we have only tried with one trial, so the result was not accurate. So we have not included in the slides. But for the first trial itself, we got like increase in phenolic content compared to the normal control, that is herbal tea.
Okay, so how you prepare tea bag using ordinary?
We purchased tea bag, which is ready-made tea bag, and we filled with the ingredients. Weighing normally a tea bag consists of 3 gram usually. So we made the tea blends according to the varying proportions of ingredients and tea, pomegranate, and we filled it with 3 gram in total.
See that medicinal value of this particular pomegranate, it's actually in the raw form. Okay. So when you're heating it, what kind of changes are being happening? That also need to be analyzed. So you have mentioned a lot of advantages like it is rich in antioxidants, antimicrobial, anti-cancer, like that. So natural form, it has all these advantages. And when you are mixing it, when you are producing it as a herbal tea, it's being heated up. Okay. What is the effect of heating on the various attributes of this pomegranate peel? That also has to be analyzed. Okay. Yeah. So apart from you have added various spices like cloves, ginger, and all. So have you tasted what are the various attributes of this particular product compared to other?
We have compared it with green tea. Usually, which is available. We are preparing it's like instant tea. So we have compared with the green tea, and we taste both green tea and our.
What do you mean by instant tea? What is instant tea actually?
We don't need much time for preparation. We can make the tea.
No, instant tea, instant coffee, these are all totally different product. Once you mix it, nothing will be there. Yeah, no granules or nothing. This your product is packed in tea bags and all, na? So finally the peel and all will be readily, like sediments will be there. So you can't call it as an instant tea. Okay. Okay, thank you.
Hi, Angel. Your work was, you formulated your work based on the sensory analysis, I understand. You had sensory panelists. Who were they? I mean, they were trained panelists or?
Ma'am, we conducted this analysis in our college itself.
College. Okay, and you used 5 panelists, you have mentioned.
Yes, ma'am.
Okay, so just for your information, when we use semi-trained or untrained panelists, 5 is totally unacceptable. You need minimum 20 panelists. You can definitely take the help of your friends, staff, etc. But 5 is not acceptable scientifically. So that is a point. Otherwise, this pomegranate peel is being used in many different products now. You can go ahead with this particular concept, but this is a big drawback that I found. Okay, even if you are using 5 panelists, don't mention, but then it will not give you a reliable result. Okay, Angel, please take care of that.
Oh, yes,
All
ma'am.
the best.
Thank you.
Judges, please note that was chess number SZ007. Now I call upon next participant, chess number SC010.
Good afternoon to all. My presentation topic is effect of different inocula on physiochemical characteristics of Jol, a traditional alcoholic beverage of Himachal Pradesh. In Himachal Pradesh, there is a number of traditional foods and beverages are prepared and consumed. In South India also there is a lot of fermented beverages are there. In Tamil Nadu, for example, in Tamil Nadu, you might have heard the term the sundakanji. In sundakanji preparation, the rice is boiled with water and it is buried under the ground. After a few days, it will be fermented and it is consumed as a alcoholic beverages. So similar to this, in Himachal Pradesh also, the fermented beverages prepared from the rice. It is consumed during the winter season to tolerate with the cold condition. My objective of my study is first documentation of the traditional method involved in the processing of the Jol. The second one is to prepare the isolate the microbes from the collected sample. Then it will be used for the fermentation of Jol. After fermentation, the quality has to be analyzed. This is my research design. First, I visited the locally fermented shops are there in Himachal Pradesh. They are getting the license from the government. Then they are running the shop. I visited the shop. Then I documented the process involved in the preparation of Jol. After that, the Jol sample was collected and it bring to the lab. And the sample was assessed for the quality evaluation. Then the microbe present in the sample was isolated on the lactic acid bacteria, yeast and bacteria was isolated. This bacteria and yeast sample yeast was used for the fermentation of Jol. Finally, the quality evaluation was done to check the quality of the sample. This is the local fermentation unit located in the Himachal Pradesh. These are the traditional process involved in the fermentation of Jol. First, the rice is cooked with water. Then cooked rice is spread on the cloth or bamboo mat for cooling purpose. After cooling, the pap, it is the traditional inoculum. It is added for the fermentation. The pap is look like just the shape is look like a idli, but it is dry and hard in nature. It is prepared from the rice flour and few herbals or few leaves are added to preparation of pap. After the pap is mixed with the cold rice. Then after mixing, it is filled in the mud pot. Then the mouth of the mud pot is closed with the jute bags or some other cloth. After that, it was left for the fermentation for 2 to 3 days. After the saccharification, it is opened and the water is added up to the 3/4 of the mud pot. After that, it is kept for the fermentation 3 days during the summer season and 5 days during the winter season, because in winter summer season it takes very less time for the fermentation. After that, the fermentation is filtered through the perforated plastic can. Perforated plastic cans are used for the filtration. After that, residue is used as a cattle fill. It is filled in the bottles and it is sold. These are the inoculum used for that fermentation of Jol. First one is the pap. It is a traditional inoculum used for the fermentation. Second one, the Saccharomyces cerevisiae was purchased from the microbiology lab. It is combined with the pap. It is used as a horticulture. Third one is the pap and the isolated yeast was used. Fourth one, Saccharomyces cerevisiae alone was used. Fifth one, the yeast isolated from the Jol was used. In sixth, the combination of isolated yeast and the lactic acid bacteria were used as a horticulture. These are the bacterial strain isolated from the collected sample. These are the yeast sample, yeast culture. These are the fermentation of Jol carried out under the laboratory condition. These are the preparation method we followed during the fermentation of those. Methods are same, the cultures are different. We use at 2% level of culture. Fermentation was carried out at 28 degrees Celsius. the effect of different inoculum on physiochemical properties of the Joule. The control sample was used as a collected sample was used as a control. The pH of the control collected sample was 3.64 and TSS was 20. The lowest acidity was found in the sample fermented with the POF. Sugar content of the Joule perform the use in a different inocula. The sugar play a major role in the fermentation process. So we analyze the reduced sugar, total sugar, and the non-reduced sugar of the product. Thus, the sample fermented with the I2, that is the PAF and combination of PAF and Saccharomyces cerevisiae, had the lowest amount of the reduced sugar and total sugar. It may be because of the higher utilizing capacity of the sugar. This graphically represents show that effect of inoculum on the ethanol content of the product. That's the I2 and I2 have the highest ethanol content. The I6 have the I2 have the highest ethanol content and I6 have the lowest ethanol content. Yield the different inocula also play a major role in the yield of the product. The I6 have the highest yield and I5 have the lowest yield. I6 was fermented with the combination of yeast and lactic acid bacteria. After the preparation, sensory evaluation done to check the acceptability. When we use the POF as a inoculum, the aroma, sourness, taste, and overacidity was increased. When we use the POF and Saccharomyces cerevisiae, it improves the color, appearance, and astringency and consistency of the product. The sample prepared with the I4 culture, that is the Saccharomyces cerevisiae alone, it has the lowest score for the taste. The sample prepared with the POF have the highest score for the taste. This is the overall acceptability. It is similar to the taste. I1 yield the highest overall acceptability score and I4 give the lowest acceptability of score. This is the principal component analysis graph. It represents the correlation, the overall correlation between the starter cultures and the physiochemical parameter of the product. From this picture, we can say that I2 is closely associated with the consistency, aroma. I2 and I3 are closely associated with the sourness, taste, aroma, and flavor. I6 is associated with the acidity. From this study, we can conclude that improved microbial strain can be used to increase the ethanol content of the product. In the laboratory level, we can prepare the traditional product with a hygienic and sanitary condition.
So, Senthil, can you please go to your results and discussion slides? Results. Next one. Sugar content, like some effect of previous one. Different inoculum on ethanol, then
Next one.
some bar charts are there, no? Okay, ethanol content was high in I2.
Yes, ma'am.
Compared to control. Okay, next one. Different on the yield of Joule means how much is being separated out. So that was high in the case of I6. So how do you justify that? The ethanol content was less in, right? Previous slide. Please go to the previous slide. No, just previous one. Yeah, the ethanol content was lowest in I6, whereas the next slide, please. The yield of Joule was the highest in I6. How do you justify that?
Maybe the production of some other organic acid may be produced, or maybe that after preparation, the solubility of the starch, the sedimentation of the starch maybe improve the volume of the product.
Okay, now you go to some next one. How do you define that control? Next, I couldn't get that specific number. Yeah, inoculum taste was almost okay for I6 and I1. Next one. Somewhere you have mentioned that control. How do you define that control?
Control
Locally
was-
available.
Yes, ma'am, local.
Control is locally available. Okay. So this work was done there.
Yes, ma'am.
Okay. So what about the association with your project team?
Ma'am, actually, I did my MSc in Himachal Pradesh, so it my MSc study.
Okay. So all this work was done there only.
Yes, ma'am.
Analysis and all?
The same institute only.
Okay. So have you tasted this?
Yes, ma'am. Got it.
So how does it taste?
Ma'am, the sour taste only, ma'am. Sour and
Yeah. Please now go to that sensory slide. Sensory table is there, na? Yeah. So how do you define that body?
what is
We
the
have various parameters like color, appearance, aroma, and how do you differentiate between aroma and astringency?
ma'am, aroma is when we are having when you are consuming that jol, aroma means the flavor.
Yeah, that's sure. Yeah.
Yes, sir.
What about astringency?
Astringency is a taste just like a bitter.
Now, what about taste?
Taste is the combination of all the things.
Fine. Thank you.
I should ask. So, what was the drawback of the what traditional beverage, traditional jol?
Traditional jol.
Ah.
Ma'am, ethanol content is just to only 4.2% like that only, ma'am. So when we are using that improved cultural strain, we can increase
So,
that ethanol content.
Alcohol content was
4 only.
4 only.
Yes, ma'am.
Okay. Whether it is alcoholic at 4%.
Ma'am?
Okay. So after this treatment, which one was how much you got alcohol ethanol content?
6.2.
6.2.
6.2%.
Okay. So it is sour taste.
Yes, ma'am.
Okay.
Hi, Senthil. First of all, about sensory scores. Most of your sensory scores are in and around 5.
Ma'am, I have used that 7-point hedonic scale. I didn't use that 9-point.
You used? I didn't get it.
I used that 7-point hedonic scale, ma'am.
Hedonic scale,
Yes,
exactly.
I didn't use 9-point.
So what I am, okay, fine. And the score was out of?
7, ma'am.
Okay, 7. Then it's fine. I didn't see it anywhere in the slide, or maybe it skipped. Another one is, how does this work help a traditional fermenter? I didn't get the novelty.
Traditional fermenter.
Yeah. Or what is novel in your work?
Novelty, we can use that new strains to improve the ethanol content, and we can improve the color appearance of the product. So we can improve the sales also. It is locally, price is only 40 rupees per 650 ml. So if we improve the taste, color, flavor of the product, we can increase the price.
Okay. And can you just tell me something more about fab? I don't know
Yes,
how
ma'am.
you pronounce. Can you tell something about it? What is it?
This
Maybe
is the
that
pop.
I1, I2, I3 you have shown, right?
Yes, ma'am.
You can show that particular slide. Yeah, this one. So what is fab actually?
PAP is the traditional inoculum, ma'am.
Okay.
In this slide, I have shown that.
It consists of rice.
Yeah, rice flour. Rice flour, they are adding some plants also.
Okay.
They are adding water, then it is dried, ma'am. It dried, it is added in the form of flour.
Flour. And does it contain any microbes?
It may contain microbes, because they are adding water, kept for some time, and then they are after that they are drying the product, drying it.
So that you used as an inoculum.
Yes, ma'am.
And
Sort of
apart from that, yeast also you have used, LAB also you have
Yes, ma'am.
used.
Yes,
Fine. And which one do you found the best in terms of quality, yield,
in
everything?
terms of
Optimized.
In terms of ethanol content, we can use the combination of the POF and Saccharomyces cerevisiae.
Yeast.
But the POF have that what's original flavor and aroma. It has that.
Okay. Only fab.
Yes.
Thank you.
Thank you.
Thank you. That marks the end of this event. I extend my deepest gratitude to all the participants as well as our judges for making this time to be with us and making this event a grand success. Once again, thank you all. Attention, the participants are requested to wait. The participants are requested to go to the canteen as their food is provided over there.
പേര് പറഞ്ഞില്ലേ ലക്ഷ്മി ഇല്ല
എന്നാൽ കാൻഡിൽ കൈ